Today's flip is going to show you the product sum rule that will help you build a polynomial expression knowing what the solutions or what the roots are. So we're going to start first by telling you you're going to have this pattern memorized. Your function is going to be equal to x squared minus the sum of the two solutions times x plus the product. And the most frequently missed part, first of all, people forget this shortcut. And the next part is your sum of your two solutions needs to have its sign switched. So I'm going to show you the old way of doing this. If my solutions were x equals 3 and negative 5, if I turn that back into bubbles, that would give me a function of bubble x minus 3 and x plus 5. You'd FOIL that and you'd get x squared minus 3x plus 5x, which gives you a plus 2x, and then minus 15. Well, the product sum rule says you find the sum of the two solutions. My sum is negative 2. My product is negative 15. And if I look at the pattern up above, I simply follow that pattern, and I'd have my function is going to be equal to x squared minus negative 2. So that's going to become plus 2x minus 15. Now, maybe it doesn't save us a lot of time when we already know how to put these functions back together when we have real solutions that are integers. The sum here would be 11. My product is 28. So this is going to be x squared minus 11x plus 28. Where it starts becoming a time saver is where we're in imaginary numbers or irrational numbers, because those sum, you always will have its conjugate as a solution also, and the product sum rule can be a time saver there. So my sum here is 0. My product is negative 49i squared. Well, negative 49i squared, we never leave I raised to a power, so that becomes positive 49. So this will build to f of x is equal to x squared minus 0x plus 49. Now we're going to deal with a complex. So the sum of this, I'm going to have 6 and then plus 4i minus 4i, those cancel. Then when we product, I just do a quick FOIL. That's going to be 9 minus 12i plus 12i, which cancels, minus 16i squared. Well, that negative 16i squared, as before, we don't keep imaginaries raised to a power, so that becomes plus 16. So that becomes 25. So this builds to f of x equals x squared minus 6x plus 25. Now, if you look at that versus multiplying it out, maybe using the box method, this is a huge time saver. So we're going to find my sum here. My imaginary is going to cancel because they're conjugates. So this is going to sum to negative 2. When you do your product, you're going to have negative 1 times negative 1, which would be 1. My middle terms will cancel. Minus 4i squared. Well, that minus 4i squared turns into positive 4, so that equals 5. So this is going to be f of x is equal to x squared minus 2, so that's going to be plus 2x plus 5. Last one, do the sum. Well, my i's cancel, so my sum is going to be 10. My product is going to be 25. Then my positive 5i and negative 5i cancel, minus I squared. That I squared has to turn into a positive, so that's going to become plus 1. So that becomes 26. So I'm going to write my quadratic f of x equals x squared minus 10x plus 26.